G'day, it's Darren from Everything Micro FPV, and welcome to the setup series for ExpressLRS. The whole concept around this series is that for each of the different steps that you need to undertake, there'll be a separate video. And the reason for that is as things change within the project and the steps adapt and improve, what we'll be able to do is remove the videos that are no longer relevant or contain incorrect or outdated information, and then swap them in for the newer videos. So I hope this entire series provides you a lot of value. Okay, so the first step in setting up ExpressLRS is we actually need to set up our radio. And if you're using something like the FrSky X9 Lite, that uses OpenTx, and most radios in FPV, the software that runs on them is OpenTx. So if you're using something like the Radiomaster TX12 or the TX16S, the Jumper T18, the Jumper T-Lite, they're all using OpenTx, but the process from a software perspective is going to be the same. Now, the first thing we actually need to do before we start the flashing process is work out what type of ExpressLRS transmitter module we're going to need. Now, on something like the X9 Lite, this uses a slim module. So that means you'll need a slim module like the one I have from Beta FPV. If you're using the Jumper T-Lite, for example, now my Jumper T-Lite's in pieces because I broke a switch, you'll probably have either the ability to connect the slim module on the back if you've got the adapter, or you can also get the Happy Model ES24TX, which bolts straight on for a native integration. Now, the other type of module for something like the Radiomaster TX16S and the Mambo or the Jumper T18 is actually a full-size or JR Bay module, and this is one here. This is actually a Ghost module that I've got ExpressLRS Flash to. You'll notice that this is a full-size module compared to the Beta FPV. So you can see that there is quite a bit of difference. And the way they connect to the radio is different as well. The full-size JR Bay module connects through this spot here where the pins go through, but the Beta FPV and most other slim modules connect through these pins. So to give you an example, I'm going to connect up my module by just sliding it in the back. You want to hear a click. So that's how to connect up the module. But before we can actually go and start all of this, we need to set up the software. So the first thing we're going to need to do before we start running ExpressLRS on any of our radios is we need to update them and make sure that they're using the most recent version of OpenTx. We're going to head to the OpenTx website and download the most recent version of the OpenTx configurator or companion. So you can Google that, and we go to OpenTx.org, the Downloads tab, and we can see that we've got the latest version here. And we're now going to download it as well. Now, the other thing that you want to do when you're downloading that is also download the SD card contents for your radio. Now you see here there's a range of different radios which you can download the SD card contents for. So if you're using the Jumper T-Lite, that's the one, Radiomaster TX12, Radiomaster TX16S, or like me, I'm using the FrSky X9 Lite. So I'm going to click on that, and then I'm going to download the most recent version of the SD card contents. Now, the other thing that we're going to need to do is go to the ExpressLRS website, expresslrs.org. Actually, we're going to have to download the configurator, which will take you to GitHub. Download the one that works for your operating system. If you are using Windows, you want to download the ExpressLRS configurator.exe. Always download the latest one, because that way you can make sure that you're running the latest version of ExpressLRS. Now we want to head back to the we're going to head to Quick Start. We're going to go down to prepping your radio. We're going to scroll down to Lua script. We're going to hit right click, save link as, and I'd recommend save this to your desktop to make it easy. And we're going to call that ELRS LUA and hit save. That's going to download it and set onto the desktop. So now we need to go through and install OpenTx Companion. If you haven't done this already, it's a very straightforward process. Cool, once that's been completed, we're going to hit next, we're going to hit finish and run. Now, once that opens, this is the first time you've ever been to OpenTx Companion. You'll need to go to settings, radio profiles, and hit add radio profile, and then select the profile name. So we're going to call this X9 Lite, and I've got a few of them, so I'm just going to put the date in there. I'm going to select the radio type, and all you're going to do is select the type of radio that you're using. I'm using the X9 Lite. Whatever radio you're using, just select the model. Now in terms of build options, all we need to do here is make sure we've got .lua selected. We don't need to do anything in application settings or simulator settings. So just leave that as simple. And make sure that you select stick model to be whatever you currently have. So if you use left hand sticks for your throttle, so that would be throttle, yaw, pitch, roll, leave that as mode 2, and your default stick order as RETA, so that's what's going to need to map into Betaflight. I'm going to hit OK. That's going to create that profile. To put your radio into bootloader mode, you hold your two trim switches, left and right, into the middle, and the power button, and then it puts it into bootloader mode for OpenTx. They're going to connect in a USB cable. We're going to hit read models and settings from radio, and that's going to import everything. The other thing we can also do to back up the radio is click back up to file, and then again we're going to call that X9 Lite October 2021 backup, and we're going to hit save. In order to update the firmware, we're going to head over and see the little sync icon where it's going to say check for updates. That's going to check the OpenTx server for update. It's going to give you an option to download the most recent firmware. Do you want to download it now? We're going to hit yes. We're going to just save that to the downloads tab, which is fine. That's going to download. And then from here, we're going to go read and write. We're going to hit write firmware to radio. And what we've just downloaded will be there. So you can see that's there as well. We're going to hit write to TX. Cool, that's done there. You also want to sync your SD card contents, so your local folder. So if you go back to where we downloaded those SD card contents, you can see here that's downloads SD card. So go back to our downloads tab, and what we're just going to do is go extract all, and that's going to extract it to the folder. Cool, so once that SD card has extracted into a folder, we're going to go and select that local folder, and you can see that's the SD card today. We're going to hit select folder, and then we're going to select the radio folder. Now, Now when we select the radio card folder, you'll notice that we've got two different drives here, Tyrannus L drive and USB drive F. Tyrannus L drive, that's the storage or the memory that's on the radio itself. The USB drive is actually the SD card. Now, just a word of warning, doing this through the radio to the SD card is incredibly slow. It's going to take a long time. It's actually a lot easier if you can to plug your SD card straight into your computer and then copy all of those firmware, copy all of those across. But for now, just for the sake of the process, we're going to select the USB drive, hit select folder, and the options that you want to hear is copy only if newer, compare contents, and then we're going to hit start. And that's going to go through the process of updating the SD card contents. Now, this could take a while, so go and find something else to do for a little bit. So once the SD card contents have copied across and are up to date, the only thing that's left to do is copy across the Lua script that we downloaded earlier to the SD card itself. So now what we need to do is copy across the Lua script to the radio. And the way we're going to do that is, whilst the radio is still plugged in, we're going to go to the USB drive associated with that radio. So in my instance, that's F drive, that's the SD card. And we're going to go into the scripts folder. We're then going to go into the tools folder. And then from here, we're going to just drag the ELRS Lua script into that folder, and that's good to go. The next step is to go and set up the model on the radio. So let's do that. I'm going to close that, and we're going to unplug our USB port. You notice this is still in bootloader mode, so what we're going to do is scroll down to exit.
Welcome to OpenTx.
Now this is the same process regardless of what radio you have, that as long as it's running OpenTx, this doesn't change. So we're going to press the menu button, and you can see we bring up the model tab. Now I've already got a model here, but I'll show you how to create a new one. So we'll go down to an empty space, I'm going to select that and then hit create model. Now in my instance, it's actually going to take me through the wizard. You could have changed this in OpenTx to not take you through the wizard every time you're going to create a model, but I'm just going to click multi for multi-rotor. We're going to assign the throttle, which is channel 1, which is fine. If you click on that, it'll flash. So I'm going to hit page for roll, pitch, it's fine, yaw is fine. Now this is where you get to pick the quad for aux1. Now with ExpressLRS, it's really important that the switch you use for arming is always aux1. The reason for that is in every packet of data that is sent to the receiver by the transmitter, it includes the 4 stick positions of throttle, yaw, pitch and roll, and also the stick position, and also the switch position of the arm switch. So whatever switch you use, you can assign that. Now you can just leave that as SA. I'll show you how to fix. No, you can leave that as SA for now, since you may not know which is SA and so forth. And I'll show you how to change that later because we're going to do that anyway. I'm going to hit page and the mode tab. So we're going to switch that to, leave that as SB. Beeper, you can go SC. And done. So we're ready to go. Press long to confirm. I'm going to hit exit. So we're now in this model. So what we're going to do to start configuring it, we're going to hit the page button to go across. We're going to change our model name. Now I might want to call this ELRS. So I'm going to go E. All of our settings, we're going to leave our pre-flight checklists. And we'll see here we've got internal RF. Make sure we have the mode for internal RF set to off. Maybe you may want to untick global functions, that's another good one to untick. We're going to change external RF to CRSF for crossfire. and you can leave that as channel 1 to 16, receiver 0. From here we're going to hit the page button, leave heli setup, flight modes you don't need to, inputs, that's fine to stay there, mixes. So this is where you set up the channel maps. So if we go down to channel 5, channel 5 is aux 1. So throttle is channel 1, channel 5 is aux 1. So I'm going to leave that, I'm going to click on that, we're going to hit edit, so double tap to hold, we're going to leave that as ARM, we're going to change the source, click on that. Now what we can actually do here is, and this is the way I like to set it because I find it really easy, is figure out which switch you want to set as your ARM switch. So I'm going to use this one up here, which is a 2-mode switch, and I'd recommend that you use 2-mode switches rather than 3 modes. 1, 2, 3. Leave that as your arm disarm. That's my personal preference. However, if you prefer something else, be my guest. But you'll notice that whilst this is flashing, whichever switch I flick is going to be set as the source. So just going to hit exit for now. And then we'll go through aux 2, hold that down, hit edit. That's going to be your beeper, that can be anything. So I prefer aux 2 to be this switch up here. I'm going to hit exit. The naming doesn't actually matter. So I'm going to hold that down, hit edit, source, I'm going to go that one, hit edit and back, channel 8, source, this is where you might want to go this one over here, which is your SC, and then channel 9, I'm going to change that to, and then we're done. That's what you need to do with mixers. Hit page, display, and then we're good to go. Now you notice on the back we've got a blue light, which is good. So let's press. What we're now going to do is hold down the menu button. That's going to take us into the tools, and we're going to scroll all the way down to ELRS. This is the ExpressLRS LUA script. We're going to see that's connecting, and if all of that works, we should be good to go. You notice here that I've got the packet rate selected, and then up in the top right hand corner I've also got this 0 to 50. So to make sure this is working correctly, if I change this packet rate to 500, what should happen is the 0 to 50 should change to 0 500. The same as before, change that down to 50 Hertz. That goes down to 50. You can also change your power outputs, so to 50 or to 25. This is going to be subject to what your transmitter can actually go to. So if I change that to 500 milliwatts, now the way to make sure that that's working on the beta FPV model, that should go to red for 500 milliwatts. 250 is purple, and 100 is blue. So to give you a quick explanation about packet rate and power. So power is just basically how much raw power the transmitter itself is going to put out and broadcast the ExpressLRS signal in. The packet rate is how quickly it is going to send those packets out. So the lower the packet rate, the slower those packets are going to be sent. The higher the packet rate, the faster they're going to be sent. Now you'll notice that there's a brackets of dBm. So that's got to do with the decibel reading for the noise and how clear that those packets are going to be sent. So the key thing to note is if you want more range and more penetration, lower packet rate. If you want Faster transmission, higher packet rate. So if you're trying to do something extremely long distance, you probably want to set a low packet rate. If you're doing racing, you probably want to set something like 250 or 500 megahertz as your packet rate. The interesting thing to note here is even on 250 or 500 even on 250 packet rate with a 500 milliwatt output power, you're still going to have miles and miles and miles and miles and miles of range. Even taking the output power down to 100 milliwatts as an example, with a 250 hertz packet rate, again, you're still going to have miles of range. One of the great things about ExpressLRS is you get so much range from the transmitter. So personally, I fly on 100 milliwatts with 250 megahertz packet rate, and I don't have any range issues at all, and I can fly for several kilometers without any problems. If you want to know exactly how far ExpressLRS can go, you can check out the website, because on the wiki there's some records about how that goes. But typically you shouldn't need anything more than 100 milliwatts and 250 hertz. The next step you need to do is flash ExpressLRS to your transmitter module. Now, every transmitter module is slightly different, so please click the video that corresponds to the transmitter module you have, and if you have any questions, drop them in the comments below. I'm Darren from Everything Micro FPV. Until next time, don't forget to send it.